In this video, we're going to look at some multiple choice questions on pressure. Pause the video now and try this question. The mixer is placed on a large flat board to prevent it sinking into the ground. Why does it prevent the mixer sinking? So pressure is force over area. So the larger the area, the smaller the pressure. So A is the answer. Weight is mass times gravity. So the mass never changes, the force of gravity never changes, so the weight never changes. So C and D can never be correct. Question 2. Pause the video now and try this question. So you might never have seen one of these before, but it's a fairly simple device. If the pressures were equally the side, then the mercury will be the same level because there is the same force either side. We have a little height gap here because the pressure on this side is greater than the pressure on this side. So we're pushing down the mercury more over here, which is obviously going to push it up. So how does the value of H change? So if the mercury in the manometer, so the manometer is this device, is replaced with a liquid which is less dense. So if it's less dense, it requires less force to move it. So the height would increase. If you put water in here, it's far easier to push that water up for the same force. So the water would be up here somewhere. If it was a more dense liquid, the height would be smaller. Pause the video and try question 3. So we have molecules of gas in a closed container of constant volume. What happens to the molecules when the gas is heated? So if we increase the temperature, pressure also increases because pressure and temperature are directly proportional, assuming we're using the Kelvin scale of temperature. If we're using degrees Celsius, then we would have, I know I've switched the axes here, which is not super conventional. If we're using degrees Celsius, we have a linear relationship like this. So higher temperature, they are going to, pressure is not one of these. So they don't expand, the molecules themselves never expand. Less often that's not true. That would be if we cooled it down. They move further apart. That's not true. They move more quickly, although on average would be a better answer, because some of them are going to move quickly, but there'll always be some that are moving slowly. Question 4. A block rests on the table. Brick is now turned so that it rests on the table on its smallest face. How has this affected the force and the pressure? So pause the video and try this question. So again, pressure is force over area, and the force is coming from its weight, so mg over area. It's the same mass in both cases. G is obviously the same. So the weight never changes, so the force must be unchanged. What about the pressure? Well, we have a smaller area, so the pressure must increase, which means it's C. Pause the video and try this question. So we have 2 barometers and they measure pressure. Again, it doesn't matter if you don't know what a barometer is because it tells you that it's for measuring atmospheric pressure. So which of these statements is true? The atmospheric pressure on day 1 is less than the atmospheric pressure on day 2. Well, the atmospheric pressure pushes down here and it pushes up the water, and the height of the water is related to pressure. That's the only thing. It doesn't matter how wide the water is. So this one is incorrect. Atmospheric pressure on day 1 is the same. That sounds correct because the height is the same. Let's just check these. Pressure at point X is less than at Y. That's incorrect. And the pressure at point X is the same at point Y. That is also incorrect. So I've made a very silly mistake here. What I've completely ignored is this height difference here. So this height difference means that actually there is a greater force on this one because it's pushed the water down more, so it pushed the mercury down more to get up here. So actually B is incorrect. D is the one that is actually correct, because the pressure at X is going to be due to the height of the water on top of it, and the pressure is the force over the area of the water on top, the same height of water, so the pressure will be the same. And actually here, the atmospheric pressure is higher in order to push this mercury down more compared to this one. Pause the video and try question 6. So what happens, the average speed of the molecules and to the pressure of the gas in the cylinder as the temperature rises. So it's a sealed gas cylinder, so temperature increases, pressure increases. So it must be either B or D. What about the average speed? Well, if we increase the temperature, the average speed also increases, because the particles will have more kinetic energy on average. Kinetic energy is half mv squared. So if the energy goes up, the velocity must also go up. The mass obviously stays the same. Pause the video and try both of these questions. The molecules of a substance become more closely packed and move more quickly. What is happening to the substance? Well, it's becoming more closely packed, so that suggests it's being compressed. It can't be expanding. And they're moving more quickly. So we've already said that the speed is related to kinetic energy related to the temperature, which suggests it's A. Let's have a look at C and D, just check we're not wrong. Boiling, obviously that's incorrect. They would be moving from very, very close together in a liquid to really far apart. And evaporating, again, they'll be doing something similar. So definitely A. Man stands on the ground. What action will increase the pressure that the man exerts? Well, again, we'll come back to the same idea. Pressure is force over area. So we need to either increase the force or decrease the area. That won't do it. This would increase the area, so that would decrease the pressure. That won't change it. If we go from 2 feet to 1 foot on the ground, that will decrease the area and increase the pressure. Pause the video and write this question. So air at room temperature is blown across this damp cloth. So as we blow the air across, that will increase the rate of evaporation of particles. And just like if you have wet hands and then you blow air across your hands, you will feel them be cooler. Exactly the same here. So it falls down. So actually this one isn't to do with pressure at all. This is to do with energy. Okay, final question. Pause the video now and try this question. So we've got a temperature against time graph for something with a fixed volume. So what is happening at time y? The gas molecules are closer together, hitting the sides of the tank harder, larger in size, and moving more slowly. So we can start to eliminate some of these that don't make any sense. The particles themselves do not change in size. Are they hitting the sides of the tank harder and with more force? Well, that would increase the pressure. That would mean a greater pressure. Moving more slowly, well, that's clearly rubbish because they've increased in temperature closer together than at time x. Well, it says it has a fixed volume, so that cannot be correct. So it must be this one. And as soon as you clock that it's an increase in pressure, you probably know it's this one anyway, because an increase in pressure does mean an increase in temperature. And that is obviously related to an increase in kinetic energy, which we already said is half mv squared, and an increase in the velocity of the particles.